Hey everybody, how you folks doing today? Big Monday? Alrighty. What are you guys up to today? Hope you had a good weekend? It was real nice and warm out, which is awesome. So, let's see where we are today. I don't think I need this one. Alright, cool. So where did we leave off? I think we missed you last week, right? Yeah, 3:14. Yeah, so on the 16th, totally missed you folks. Slept right through the alarm. Apologies for that. So we got to finish up inheritance. We got started on it here. And let's see, then we'll see it. I think we can finish up inheritance today, and then we'll see if we can get started on arrays. We won't get to array lists necessarily. Let's see how we're doing here. Yeah, so we'll finish up inheritance, get started on arrays. With all of chapter 11 is arrays, and then just array lists from chapter 12. Good morning, Ben. Yeah, so we don't finish all of chapter 8. So there's a lot of things in chapter 8 that we don't get fully into. So I'm not planning on a quiz on chapter 8. We'll get a quiz on chapter 11 once we finish chapter 11. And then file IO we don't do all of, exceptions we don't do all of, and then Java FX we do all of. So I think the last quizzes we'll have will be chapter 11 and chapter 17 because we can cover all that content. That sound like a good plan? So let me get IntelliJ fired up here. We'll see. Also get GitHub and see where we were for our last commit. All right, awesome. Get some of these loaded up. I mean, you can definitely use either one. The SPJava, yeah, I think we'll have some time after class. We can chat for sure. NetBeans is okay. It's just kind of slow, a little bit annoying. Definitely works. I think IntelliJ is a little smoother and cleaner. So if you're up for switching, go for it. If you want to keep going with NetBeans, it'll definitely keep working. It'll just be more of the same. That's all. So all the Java code itself is the same. There's no changes there. All right, awesome. So we got through inheritance and testing. Fantastic. With our taxable item. Yeah. So if it didn't see your Java, your JDK, we'll have to go and change it or add the JDK. So NetBeans, we told it where it was on the install. With IntelliJ, when we make our project, sometimes we can put it. So we go File and New Project. As soon as this one finishes loading. Maybe. There we go. So I'm going to close this project down. And then we'll start up a new project. This one's going a little slow too. That's okay. So my laptop, I found out, is just over 3 years old now, which is sad. Computers don't last as long as they used to, but so definitely due for a new one. I got to figure out. I think I'm going to get a desktop though. I think that'll work out better. Those usually last a little longer, and then the components are a little more replaceable. We'll see. We'll see. So I'm on the hunt for a good desktop. Oh man. Come on. There it goes. Okay, so it's closed. Finally, we got it. So we did some basic inheritance. Yeah, so actually, I think we're pretty good on inheritance. I don't think there's too much more we need to cover with our item and taxable item from last week. We did the superclass constructor. Yeah, I think we're in pretty good shape. So in IntelliJ, right, for a new project, we're just going to go new project. And then just a basic Java project is all we need to get started here. If you, again, it should have the OpenJDK. If it doesn't, you can go to Add JDK and tell it, hey, here's where my JDK is. It'll even like automatically go and download one for you, which is pretty cool. It's got some nice bells and whistles here. But if you want to keep using the OpenJDK, it'll keep life nice and easy for us. You just say, hey, let's go add the one, and you go point it to that location. So again, we put ours in OpenDev, or not program, C, OpenDev, and you just say, here's my Java JDK, and you say, okay. It would go find it. So it's pretty quick to add that. If you have any trouble, let me know. We can definitely hop on a screen share. And then we do want to make it from the template, this command line app, because that gives us all of our starting code. Otherwise, it's empty. We'll go next. We need to tell where do we want to put it here. So I want to make sure I'm in my Monday, Wednesday folder. And then what do we want to call this project? This will be arrays and array lists. So it gives you the base package name by default, which is fantastic. Right? Package name, just like we were doing in NetBeans. So we've got that subfolder, because you don't want to use the default package. It's just a little bad form here. So let's actually, let me change the title of this. I think I can change it like this. Uh-oh, the API failed. All right, I can't change the title there. That's okay. Put it in the wrong folder. I really thought I put it in a folder. It didn't. All right, so I messed it up. Let me close this again. Because I want it inside of a folder, is what we want. We don't want all this stuff right inside of our main. Yeah, I'm going to go get rid of all these. I'm going to discard all the changes. We don't want them here. Try one more time, a new project. From the command line, or template, documents. We'll find our GitHub folder. 1500, Monday, Wednesday. Flash, here we go. Now we get a folder name. So this is arrays and array lists. And we have to tell it we want it inside of a folder called arrays and array lists. There we go. That's the part that was missing. Otherwise, it's just going to be all jumbled together here. This will put it inside of a folder for us. And it says, okay, the folder doesn't exist. We want to make it. Yes. Here, now we did the right thing here. Now it'll be in a nice little folder and be a little cleaner for us. When I look at my project, it just has the arrays and array list folder. There we go. This is what we want. And then we can start our code in here. Okay, so we did have that lab from last week. I forgot, do you want to go over that lab first before we get to arrays? We had our inheritance lab, was due this morning. Should talk about lab 9. We could do lab 9 first. So we do one more new project. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. Got it out in one breath. Lab 9. And Lab 9. Why didn't they change the package name? It's crazy. All right, so we got a Lab 9 folder. Last week was Giving Blue Day. Hey, Ernestinance. How you doing today? Yeah, last week was their Giving Blue Day. They had their big fundraiser challenge push and all sorts of interesting stuff, and then their website crashed, which was, I mean, kind of cool that enough people wanted to give money that it crashed their website, but also like really sad that you crashed their website. So I think I finally got my donation in about like 11:30 p.m. or so after it was down for a couple hours during the day. They're like, it's back up, but it's flaky. So question for folks in the chat: does anybody try and copy all of my code on their own time, like kind of follow along after the fact, like rewatching it? Yeah, instead of just copy pasting, if you start building it from scratch. So we'll make our Lab 9 folder. We'll come back to arrays and array lists in a minute. We've just got to tackle lab 9 here. I think, Ernestin, it's are you in the class, or are you just hanging out with us, though? That's the fun part. I don't actually know who is actually a student and who just wants to hang out for fun. Okay. Yeah, so I think any other students in chat, if you go through the code on your own. All right, so for the lab, we wanted to make some classes here. We're going to make a rectangle class with attributes for length and width, get and set methods for both because they can change, and then methods for get area and get perimeter. Okay, we can do that. So we'll start with a rectangle class. So we need to go to our source folder, and we're going to right-click and say we want a new Java class. Call this one rectangle. Okay, and then that's fine. We can add it right away. For private attributes, so this idea of encapsulation, we're going to take all of our details for a noun, some sort of class, and bundle them together here. So we want private details. We're going to give them public methods. So we want a public int for length, and a public or private int for width. Private variables here, and then we're going to give them public methods to give them access. So I'm going to right-click, and I want to do generate code, because I don't have to write these methods myself. So we want getters and setters. Oops, getters and setters. Got the wrong button there. Clicking too fast. For length and width. Now, again, there's no checkboxes here, so you want to hold control and click. We'll highlight multiple of those. And now we have methods for get length and set length, get width and set width. Right? Gets and sets for both. Then we want to do get area and get perimeter. Okay? Now, and again, we probably want to do some sort of sanity checking here. We can say, hey, like, if the length is greater than 0, let's go set this one here. Because one of the ideas here with writing our classes is we want to maintain the integrity of our class and make sure you can't put me in a bad state. So if you give me a negative length, I'm going to say, no, you can't be negative. We'll assume it's 0, which I guess you can't have a one-dimensional object either, but 0 is probably safer than anything else. So this wasn't required for the lab. This is just a nice practice to be making sure our variables are good here, making sure we're getting good values. Else my width is going to be 0. And then, was it Control-Alt-L? Yeah, for formatting. There we go. Give it a little format here. So now we have rectangle. Set and get methods for length and width. And now we need to add methods for get area and get perimeter. So we don't need to track values of area and perimeter because we can calculate them here. So I'm going to add a public int get area. That's going to return length times width. And then a public int get perimeter. Perimeter, that sounds right. We're going to return length times 2 plus width times 2. For our purposes, it's not going to hurt anything. It's good practice. So if the value is public, someone can change it outside of your class here. So if I mark these here as public and public, what I can do here in main is I can say, hey, I want a rectangle equals a new rectangle. Right? I can use that new keyword to create a new instance of this, and then I can say rectangle dot. And when I say rectangle dot now, I see all of the public methods and any public attributes here. There's a bunch of other stuff. Don't worry about the other stuff right now, but I could say, hey, length equals -10. Because I have direct access to this attribute, because we've marked it as public, I can go and change it directly and give it a value that is completely inappropriate. Right? You can't have a rectangle with a negative length. Our method makes sure you can't do that. But if you have access to it, you can do anything you want to it. So it's part of maintaining the integrity of the class here, is we want our attributes to be private, and we want to give people access to them with public methods, because those public methods can do these sort of sanity checking things here. Right? Make sure the length is proper, make sure the width is proper, those sorts of things here. So private is best. You're not going to lose any points for it here. It's no big deal. But you want to make sure that so if you mark them as private, then I don't have access to them, and I can't change them. And now it's going to yell at me here, says I can't get to length. So notice it turned red here. Length is private access. So I'd have to call set length here. And if I tried to give it -10, then our code is going to say, oh, nope, can't be negative. It's okay. It wasn't a requirement at all. This lab was just practicing writing here. But that's, as we're getting into writing classes, that's one of the reasons we like classes, is because we can control the values of those attributes here. Oh, sorry, this should be this.length. There we go, and this.width. So it's nice. It's telling me it's just kind of graded out here. It said the value 0 is assigned and is never used because it's not my this attribute. It's not my class level attribute. I was actually changing the value of the argument. So NetBeans was giving you, I think, green and purple, or orange and purple. Some of the coloring is a little funny. Okay, so we've got rectangle. Now we could also, if we wanted, add a constructor. Now we didn't need one. There's no requirement for adding a constructor here. But if we wanted to, right, to make it easier to use our class, so like in main, when I make a rectangle, then I have to call rectangle.setWidth and setLength and say, oh, okay, let's actually make this, let's do valid, like a 20 by 10. Now I have to spend 2 more lines of code to do this. Not the worst thing in the world, but if we wanted, we could add a constructor. Again, constructors are special, right? They don't have a return type. And all they have is the name of the method matches the name of the class, and then I can say, hey, give me an int for length and an int for width. Here, so this one's optional. Oops. Optional. But good to have. Right? They're nice to have. So then I can say, hey, let's set length given the length, and let's set width given the width. Right? Again, we don't want to reinvent the wheel here. I already know how to do these checks for 0 or not, so I can use sets. I can use my set methods. They're handy. Now here in main, it's yelling at me, and it says, hey, rectangle int cannot be applied to parenthesis. So the message here is a little bit different, and NetBeans is like can't be applied to given types, requires int found nothing. So we didn't give it any arguments. We need to give it a length and a width here. And now, okay, here's the length and here's the width, and then I don't need to call set length and width. I can do it separately because it happens in the constructor now. Okay, so the constructor's handy. They're nice to have. So then we're going to make one more class. We're going to make our square class here. Square. And we're going to use that keyword. We're going to say we extends rectangle. And we are a rectangle. We can do all the things rectangle does here. Now, if we have the constructor, it's going to yell at us because it says there's no default constructor. So what we need to do is so if we went the constructor route, we have to have our own constructor. And then we need an int for, what is it, like length or something for a square. And then we need to call our superclass and give it the length and the length. Right? This is only if rectangle has a constructor that requires arguments. We have to give it that. Then we wanted to go through and we wanted to override our methods for set length and set width so that both of them are changed. So if you try and change the length or the width of a square, they both need to change because they need to stay in sync. So remember, because a square is a rectangle, if I were to make a square now, square equals a new square, given that we'll say this is like a 10 by 10. Now, square right off the bat has methods for set length and set width because it is a rectangle. It gets all of the public methods of rectangle because of inheritance. So what we need to do then is we want to go override. So I'm going to use this add override annotation to make sure we do it right. Again, this gives you checking to make sure we spelled everything right. So I can say, hey, public void set length here, int for length. And if I typoed one of these things here, because I typo things all the time, it's going to tell me, hey, you're not actually overriding anything here because I misspelled length. So it gives you another level of checking to make sure, yes, you actually look like you have the same method signature as your parent class, as your superclass. Now, if I need to change both here, what I want to do is I want to call super dot, because super dot will give me my parent or my superclass's version of set length here, and super dot set width, given the length. So I want to say, hey, superclass, you go set length and set width, please, of the new length. And we do an add override again for public void set width, given an int for width. Oops, that was a curly brace. And I want to do the same thing, set the length and the width here. Now the reason the super is so important here is, width. If we don't say super, we can just say, hey, I want to call set length. Set length now calls my set length. So my method calls my method, which says call my method, which says call my method, which says call my method. It's going to loop forever. We'd have an infinite loop here. So we need the super class version of set length, which will go and set the length. The other thing we need here, because these are marked as private, here, Square can't actually touch them. I can't say length. Right? I can't go get my, there's no this dot length. I can't get a this length here because it has private access. Even though I am a square, even though I am a rectangle, I don't have access to it outside of the rectangle class. So private says the only place you can access this value is in the rectangle class. Now, because these methods are public, I can call getLength and getWidth. Sure, no problem. I can use any of the get methods I wanted. Those are fine. Okay. Then we wanted to write some unit tests for rectangle and square to make sure they work. For square, test that it changes both. Now here's where it got a little tricky because I didn't actually finish that, did I? So to do our tests then, this was a little bit more obnoxious because we didn't make the project the right way. So let me try that again. Let's try the other project here in IntelliJ, because I think it would make life a little easier. So instead if we used Maven, it was going to work a little nicer for us. Let's try it real quick, if you don't mind. So this is Lab 9 test. Sure, it's just going to put everything together for us. Why not? Lab 9 test, Lab 9 test. Let's try it. Or Lab 9 testing. It's not even, that's fine. We'll call that. We'll see what we get. I'm going to do it in a new window. I want them both open at the same time because I'm going to copy paste a bunch of stuff. We're going to see if the testing gets created a little easier, because NetBeans, you can just right click and go to test. It'll make it all for you. So I want to see if this will work for us. There we go. Okay, yeah, so we already get a test folder, which is really cool. So that's kind of interesting. I think we're in a pretty good spot here. Let's see. So let's add some new classes here. Let's see, can we add some Java class? We'll call it rectangle. We're just going to go copy paste rectangle over. We rectangle. Oh, goodness. Sure. We'll come back to that. All right, so we're going to go to rectangle. Drop that in here. Oh, we need a package again. We need a new, my goodness, package. Lab 9. We'll drop that inside of Lab 9. Okay. All right. Making sure this all looks happy here. We got rectangle, and then we're going to add another class for square, and we'll copy square over. It's fine, it's fine. Maybe square, square, all of this to make the testing easier. Promise. I promise. It'll be easier. Sure, it's fine. There we go. So now we got square. Okay, so we have square, we have rectangle. I think it's okay so far. Oh, I misspelled square. Look at that. S-Q-A-U-R-E. So it's telling me it should be in the file name square. So we got to fix that. So let's refactor, rename the file to square. Okay, now it's happy with how it's spelled. Okay, now we want to go look at our tests. So we're going to right click and we want to, where is it here? Go to test. Now this should work because we did our Maven project. Let's see if this works for us here. Go to test. And we want to make a new test. Yep. Okay. Now the JUnit 5 should work fine with Maven. It didn't work with Ant that we were using before in NetBeans, but it should be fine for us here. And it says, hey, what do you want to test for us here? We want to test anything. We want to test set length and we want to test set width. Right? the gets here, we do want to test, but we're going to test them when we actually set the values here. Right, kind of that idea. Now let's see if it does it right for us. It's fine, yes, add it. And now we have some test code. Perfect, okay, this is what we wanted. So it adds it into the test location for us automatically, and life is pretty good. It's fine, it's fine. Uh-oh, why is it not like this one? Add JUnit to the more actions. What do we get here? Enable auto optimize imports on the fly. Is that what we want? Maybe? Is that going to cooperate with us? Let's just see if it builds here real quick. Let's build our project. It should work. We're trying it here. That's what we get for using the new tool. Thinking about it. Package doesn't exist. Yeah, we have to go get the package, please, friend. All right. So let's try adding JUnit. So this is using JUnit 5, not 4, which is weird. That's fine. So let's add it to our class path. See if that works for us. Aha! Now we go download it. There we go. Look at that. And this is what you want these tools to do for you. You want it to do all this cool automatic stuff, which is fantastic. I have to sneeze here. Give me 1 second. Sorry. Woo! Sorry about that. I didn't think it was going to work. All right. Now we got it sort of set up there. Sorry for all the trouble. We wanted to add it to our class path, and it looks a little happy here. Okay, so in our test, so we want one more test as well, right? We want to, this one we want to test constructor, really. So this is constructor. Okay. Then what we want to do, we're going to arrange, we're going to act, and we're going to assert. So to test that the constructor works, we're going to have an int for the expected length. We'll say is 5, an int for the expected width is 10, and then we'll have an int for the expected area is going to be 50, right? And an int for the expected perimeter is going to be 5 doubled is 10, 10 doubled is 20, it should be 30. Right, so these are all the values we expect to get back out. So we're going to act. We're going to call our code. So we'll say rectangle equals a new rectangle. And we'll give it the length, the expected length, and the expected width. Right, so this is the code. We looked at using the Maven project, SB Java, to make the testing just work a little bit easier. It automatically gives us all the folders and things, so we don't need to do any of that other stuff. Yeah, not other than that, we were just getting the project set. So we're just now writing our first test. Your Wi-Fi knows it's Monday. Oh man, I'm almost out of coffee already. I'm gonna have to go refill soon. Right, so these are the things we expect you to have. Now we're gonna act. We're gonna call the code. So we're testing the constructor, sets the values properly, and then we can also kind of test all the gets. Right? I don't usually like testing gets separately because you can't test a get without a rectangle. And if you're going to make the rectangle, well, really, let's just do all this here at once. So then I'll have an int for the actual length. Actual length is my rectangle dot get length. And then I'll have an int for the actual width is my rectangle dot get width. And an int for the actual area, rectangle dot get area. And an int for the actual perimeter. No, not you, Cortana. Go away. I think I might have turned that off because that's not as cool as I think it should be. Perimeter, rectangle.get perimeter. Yeah, it's just a couple steps getting it set here. So just leave yourself a note about half an hour in if you want to see that project type. All right, so we'll get all the actual values out. So we'll call the code we're testing, right? This is the code we're testing. run the code we're testing. Testing and get the actual values. Right? These are what the rectangle thinks the values are. So as far as the rectangle class is concerned, whatever we get back from these get methods are the actual values. Right? This is what we expect to get, and then we're going to assert, did we get what we expected? So we'll assert equal here, equals, assert equals my expected length, come on, expected length, and my expected width, or my actual length. Wow, the type ahead is not working there. Right, and we'll do that for each of these. 3, 4, and 5. So actual length, actual width, actual area. Oh, we only have 4 of them. Actual perimeter, I can't count. Right, and then expected width, expected area, and the expected perimeter. Okay, so now we're going to test that constructor and the get methods, I guess. Constructor and gets. Sure. So we'll call it what it is. It's testing that and the gets. Well, let's give it a try. So let's run our tests. And we should get this really cool test explorer output. Let's see if we see that in here in a second. Build finished. There we go. And now we get our cool little test viewer here. And it passes. We get a nice green check mark. Again, if one of these failed, we would get a red X here. So let's do the set length and set width here. So now we only really care about some of this stuff here. So I'm going to copy all of it just to make my life a little easier, but I'm going to pull out most of it here. So I only care about the length here, right, in my testing. So if I give it a negative value, I should get back a 0. Right, so we don't actually really care what these ones are. We can say 0 and 0. And this, really now the constructor is part of the arrange here. We need a rectangle to exist, but then the code we're testing is the set method. So I'm going to call my rectangle.setLength, and I'm going to say, hey, how about -10? And I'm going to say, is it actually 0? Right? If I give it a negative value, it should stay at 0. Right? Or I mean, it could be whatever value it was before here, but we should expect it to be 0. So this is negative is set to 0 or something? Sure. We want to give these tests a nice descriptive name here. You know, let's leave it as 10 here for just for fun here. And we want it to fail for a second, so you can see what that looks like when it fails. So I can just click the little run button here. We'll run it, and it'll run just that one test, which is nice. It's still got to go through the whole build process. It's a little slow, but it's relatively quick. Let's see. And now we get a big red X here, or I guess orange X. It says it expected a 10. It actually got 0. Right, so we can see where it failed. Really nice. And now it's giving us that warning here. So let's put that back to 0. And I'm going to just copy paste this one here for our set width test. And we'll have an expected width now, and an actual width here, and a get width. And then the expected width matches the actual width, and we need to call set width. Right? And then again, I'll rename it here, negative set to 0, because I like my tests to be named really nicely. Let's go run them all. So we can go, let's just like run all the tests here in our little test explorer. Well, I was just rerunning one of them. Shoot, I want to rerun all of them. Let's just we'll let that finish, and we'll go rerun them. Okay, so that one passed. Now I want to run all my tests. Let's just go run it. We'll run all of them for me, and we should see all 3 pass. There we go. So the set width is the constructor set. So one of these ideas when we talked about testing is this idea of code coverage, right? So when the tests are running, how much of the actual code in our class is being ran? Now, if I had never tried a negative value, this line of code here never would have ran. So we know that our constructor calls set length and set width. But if we give it good values, then line 28 runs and line 40 runs. So unless I tested using a negative value, I have no idea if this will actually do what I expected it to do. So this idea of writing our tests here and trying to get to that 100% code coverage, we need to look at every time we've got a block here, make sure we think that block of code will run. And again, there's tools you can pay for that will actually measure that sort of thing for you, which are super cool. But you know, it's, again, we're just going to kind of eyeball it here because we don't want to pay for those tools, okay? So then we have some tests. So then we're going to do the same thing for square. So I'm going to go to my square class here. I'm going to right-click and say go to test. Yep, we want to make new tests. Square test, great. What do we want to test? Set length and set width, fantastic. And sure, we'll go ahead and add. I got to check that box here. So we're going to arrange, we're going to act, we're going to assert. So for testing length and width in square, what we're testing is that length and width both change when I call set length. We're testing that both length and width change when I call set width. So I need an init for expected length. We'll say it's 5. So I'm going to make a square. Square equals a new square. And even, we'll just say 0, right? For now, it's fine. 0 is okay. Then the code that we're testing is square.setLength. I can't spell square set length given the expected length. So if I give it an expected length here, do now both length and width match. So I'll have an actual length is my square.getLength, and I'll have an int for actual width is my square.getWidth. And then I want to assert do they both match. So I'm going to assert equal that the expected length. Wow, that one's annoying. Expected length. There we go. Expected length. There we go. Is the actual length. And the expected length is the actual width as well, right? Because they should match my actual width. No, so main is not really as testable. There are ways to do it, but we're just going to pretend you don't. So really what we want to test is class code. So anything that we're writing our class for, we can make an instance of the class, call the methods on the class, and that's what we're testing. We're going to just say testing main is too hard because you can, but the sort of things that it does generally are trickier to test, especially when it deals with input and output. So if you're asking the user to enter a value, it's doable, but more trouble than it's worth for right now, at least to say, hey, here's a pretend value that you can go and pretend to read off the console. Right, or if you're testing, hey, did it print something to the screen? There's ways to do it here, but again, it's more trouble than it's worth for us. So that's one of these things here is that if we can unit test our classes, it's going to help make sure our classes have good design where our classes have nothing to do with console input and output. Classes don't print anything to screen. Classes don't read anything using that scanner class. Right? The class says, hey, you give me an argument here. You tell me what the length is as an argument when you call the method. I'll do the correct thing here. So this is testable because we can write the tests passing it values here. Right, and then set width is going to be the same thing here, but now we're going to call set width. But still both length and width should match our expected length. So let's go run these tests. Let's see if these ones pass. Let's see how it goes for us. I got my fingers crossed. All right, set length and set width pass. So they both ended up changing, right? We started off at 0, and they both changed to 5. All right, so that worked out a lot nicer than the other one here. So with the other version, you can still add tests, but like the go to test doesn't really work. I mean, I think it did, but it put it in the wrong folder, and then I was sad about it here. I think that was the whole reason. So, hey, Bonk. No, we don't do a whole lot with the Spring Framework. We're still focused on some basics here. But the Spring Framework's great. It's just we're focused on the basics here for our class. All right, so I'll close that one down. I'll close this one down. Oops, actually I want to leave it open because we're going to open the next one here in a second. Okay. So then we can come back to all the files changed. So there's a bunch of stuff here. Don't worry about it. A bunch of things. Anything that's in the .idea folder is okay. It's not going to be a big deal here. I thought, yeah, so it added something to the git ignore. So it added, we should ignore a couple things, and that's good. So we'll say this is lab 9 with tests. Here we go. We'll commit and push. Man, that took up almost our first hour. Okay, all right. So how about before we get into arrays and array lists, why don't we take a break now? We'll go refill our coffee, and then we'll come back in 10 minutes. We'll pick up the new stuff. Otherwise, we'll do like 10 minutes of new stuff and then break. Is that okay? So I'll just open my recent arrays and array lists project, and we can go from there. Does that sound like a good plan? I'll put some music back on. We'll come back in 10. All right, awesome. You guys like it. We'll come back at, what does that put us right at? 10:58. Okay, be back in a minute. Alrighty, friends. Oh, we still got one more minute, but just about back here. We'll let this finish up. Yeah, 20 seconds left. There we go. There we go. Alrighty. So, any questions, thoughts, or concerns? Hey, Bonk Boy. Not in this class, no. We get into them briefly in our object-oriented programming Java class, and then a little more in our data structures course. This is our intro to programming course, so we don't really get that deep. All right. So for the project, right, our electric vehicle class, it has a little bit more interesting stuff happening here. This charge method should have this parameter of kilowatt hours to charge. We're going to add the kilowatt hours to the current kilowatt hours in our battery, making sure it's positive, and then the current doesn't go above the max. So if I say, hey, let's charge 1,000 kilowatt hours, and the battery only holds 200, right? We're going to stop at 200, and we'll return a false saying, hey, you tried to charge too much. Or if you give me a negative value and say, hey, let's charge a negative amount, we'll return false, and nothing changes with our current kilowatt hours. But if I say, hey, let's charge 10, and my current kilowatt hours is at 100, and the max is at 200, we can go from 100 to 110, no problem, we'd return a true. Right? So the successful charge is within range here. If you went above the max, we still tell them false, but we're going to change it and say, oh, we'll charge you up to the max, you just try to charge too much. Similar with drive, right? The kilometers to drive here. Probably after 3, SB Java, send me a message and see. So I have an afternoon class, but usually we end by 3 for that one, so it should be okay. Yeah, just shoot me an email. So for driving, right, a parameter, there we go, there's a typo, calculate the kilowatt hours required to go that distance, right? One of the things we have is the kilometers per kilowatt hour. So if your vehicle goes 3 kilometers per kilowatt hour and you want to drive 9 kilometers, 9 kilometers divided by your 3 kilometers per kilowatt hour would give you 3 kilowatt hours required. So we'll subtract that from our current kilowatt hours. If it's negative, we stop at 0, return false, say, hey, we ran out of energy, return false. If I told you let's drive a negative amount, otherwise we'll return true, yes, we drove that amount and we changed our current kilowatt hours. Okay, and then the 100% code coverage. So we need to, for each of these, right, there's 3 different things that can happen. It could be negative, it could be above the max, or I'm sorry, below 0, or it just works properly. So we're going to have 3 different tests there to make sure we get that 100% code coverage. Oh, to meet up both? That's fine. We should be okay. I got you. Okay, so if the Wi-Fi is not working, I'm sorry, I'm a little confused, but I got you now. Okay. So that's our electric vehicle class we're going to be testing here for Project 3. That one's due on Wednesday. So let's focus on this one here, make sure we're feeling good about that one. No, actually, I want to say that I fixed a typo there, right? Fixed my typo. Then we want to talk about arrays and array lists. So we'll start with a pretty basic example of just arrays, and then on Wednesday we'll finish up with finish arrays and get to array lists. Okay? So one of the things that we've done so far is, let me pull up, my Windows key is not working like it should, which is super weird. This laptop. Just gotta find a good one. We'll find a good desktop. And I gotta move, I have a new decoration here. But I think I need to move it to the other side so that it's over there, covering the other window pane. turn off game mode. I don't think game mode's on, is it? I don't think it is. Game mode? Did it get turned on? I didn't. So I know it used to pop up. It is on. My goodness, my friend, you have just solved so many problems for me if that does the trick. You know, it's annoying in games when you hit the Windows key and it works, right? Oh, still, I'm hitting the Windows key and it's not bringing up the menu like I'd expect. Maybe I need to reboot after turning off game mode. Let's see. Maybe. No, okay. That's a good thought, though. I appreciate that. Like, usually the shortcuts will do something. No, no. So it's like, it's not registered. I think it's my laptop, because like if I hit a different menu option, and then it'll work okay. Super weird. Super weird. Alright, so if we wanted to store a value, right, we said, hey, I want an integer, and I'm going to call this score 1. Java says, hey, operating system, I need a spot to store an integer, which is, what do you say, 4 bytes of memory. So your operating system says, sure, Java, here, you can store it at x2349, and we're going to store, we'll say, 99 is our value here. And then we say, hey, Java, I want another integer, we're going to call it score 2. So this is score 1 is here, score 2, it will say, Windows will tell, or your operating system will tell Java, sure, have x394a, and we'll store 100 there. And we say, hey, I need a place to store score number 3. And it gives you another one, and so on, and so on, and so on. So you can do it one at a time, but it's a little bit annoying to have to manage all of that. So we can say int score 1 is 99, and int score 2 is 100, and int score 3 is, we'll say, 95. Right? We could do all that. We'd have 3 different locations to store these in memory. Now, let's do a couple more. Why not? So we'll do score 4, we'll say 92, and how about an int score 5 is a 94. Everyone did really well, right? We did really well on this, but now we have 5 different scores. Now, how would I go and find which is the highest score, or which is the lowest score, or what's the average score? Well, I'd have to look at each individual one and compare it to all the other ones. I could do that, but it's going to be a lot of typing for me. And you know me, I'd rather not type things that I don't have to. So what we can do instead now, we can use a new type. This is an array. We say, hey, I want an array of scores, and then we use these square braces. Square, not scare, square braces. Equals, and now we have to use the new keyword here, new int, of, and we have to tell it what size. Well, I want 5 of them here. So we use the square braces when we declare it, and then we use the new keyword, type, and then square braces with the size or number of values inside of it here. So we have the type, and then we have the name, plus square braces, equals, use the new keyword, and then the type number of values. So what this is going to do, so with integers, generally it will make copies for primitive types. For reference types, you'll get 2 values pointed at the same memory address. It's generally pretty good at your primitives. It just makes a copy. Yeah, we could try it. We'll say equals score 1, and then we'll print score 1 plus score 1, and then we'll go change. Then we need score 3. Score 3 and score 3, and if we change score 1, we'll make that 100, and we'll print them out again. We should get separate values. Let's see what we get here. I think it makes copies. So we should get 99, 99, and then 100, 99, if it did what I expected. We'll find out, bonk boy. Yeah, so it's going to make a copy. So for primitive types, you'll get the copies. Works out pretty nice here. Yep. So with this scores array, what it's doing out in memory, when you say, hey, Java or operating system, I want to store my scores, and I want 5 of them here, right? Or int scores, sorry, equals new int of 5. This one here. This tells Java, hey, I need a place to store 5 integers. So your operating system says, oh, sure, an integer is 4 bytes. So 4 times 5 equals 20 bytes. So it says, sure, you can use x 4, 5, a 0. Go for it. What you're going to get here then is 20 bytes of memory where you can store 5 integers. So in the first 4 bytes is that one, the next 4 bytes is that one, the next 4 bytes is this one, the next 4 bytes is this one, and the next 4 bytes is this one. So this is 45A0 right here. Right? This is 45A0, that's a 5, plus 4 bytes is 45A4, plus 4 more bytes is 45A8, plus 4 more bytes is 45A, let's see, so we get 9ABC, AC, and then 4 more bytes is C, we get D, E, F, and then A changes to a B. So we get 45 B0. Again, don't worry too much about the hexadecimal addressing stuff. It's not all that important. But the idea is you get this range here of memory up through, and then B through B3, right? X4, 5, B3, right? Because B0, B1, B2, B3. So 0, 1, 2, and 3 is the next four bytes that you need to store that integer. So you get a contiguous block of memory here, large enough to store all the values that you need. And you can ask for a lot. You can have 100, you can have 1,000. You can get crazy large if you want to. Again, you probably don't need 1,000,000 depending on what you're doing, but we could, right? And it will, hey, here's a big chunk of memory you can go and use. Go for it. So if we did a million bytes, so a kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes, essentially. There's a little bit of rounding there. So if I said 4 million, or if I said 1,000,000 integers, it would use about 4 megabytes of memory. Right? We have like gigabytes of memory, so we have billions of bytes of memory. Right? So we can store lots of numbers here if we wanted to. Again, depending on what we're doing here. But now what I can do is I can get at each of these values one at a time. So to get at them, I would say scores, square braces. You read this as this is variable index of. Right, so the square braces mean index of. So you can set or get the value at that index. So scores index of 0 is the first one here. We'll set to, what do we do here? We had 99. We can say scores index of 1 equals 100. Scores index of 2 equals, what do we say? That was going to be, sure, 99 again. Why not? 99. Scores index, or here, we can repeat it here. We'll say this is scores index of 0. Right, so this is getting the value. This is assigning the value. So assigns on the left, get on the right. Right, so if you're just accessing the value, you're getting it here, or this one is assigning the value. So it depends on which side of the equal sign you're doing this on. And then we had a 92, and then we had a 94. Scores index of 4 equals 94. So you notice we have 5 items, but we get indexes 0 through 4. 0 through 4. Now the reason for that is this math that has to happen. So your variable, this scores, starts at 45A0. And what it does, if you want to get a particular value out, so you take scores plus the index times the size of an int. So if you're storing integers, it'll be 4 bytes. If we're storing doubles or characters or any other sorts of types, it'll be a different size perhaps. So if the index is 0, we're going to get the first location, 45A0, because 0 times whatever the size is this starting location. Right? If the size is 1, we add 4 bytes to that, we get 1. If the size is 2, we add 4 more bytes. If the size is 3, we add 12 bytes. If the size is 4, index 4, we add 16 bytes. So 0 is always the starting index because it makes the math easy. So when we start counting, we always count with 0 first. So index of 0 is the first value, and you never have an index at your size, or at your length here, size of the length. Okay? So what we do with arrays is really kind of to loop through them. So we'll say for int index is 0, index is less than scores. Now, they have a length property. So an array will always have this dot length. This is a property you can go and access. It's not a method, just a property. We'll say index plus plus. And for this case, we'll just print out here. So we'll say scores at index plus the index plus, I don't know, equals maybe? How about the equal sign? Plus, now I want scores at the index. So this will do the get the value at that index. So we'll say scores at the index of the, index variable. We'll index 0, index 1, index 2, index 3, index 4. 5 is not less than length. It doesn't run at 5. And we'll get the value out. Scores at the index will get the value out here. So we should get 99, 100, 99, 92, 94. Let's give this one a run. I got to downgrade to the Unity edition here. I don't want to be using the educational one. Okay, 99, 100, 99, 92, 94. So you get values out by index here, which is really fun. So now, right, some of those things we said, what do we want to do? What was the highest, what was the lowest here? Let's say, so we have an int for highest score. We're going to assume is the first score until I know otherwise. I'll have an int for the lowest score. It's going to be the first score until I know otherwise. And then I want an int for total score. So we're going to start off at 0 here because I want to calculate the average. To get the average, I need the total divided by the number of scores. Now I'm going to loop. Again, same thing here. There's an enhanced for loop. Enhanced for loop is read only. So this read only is important. You can't set values here, but I can say for int score in scores. So what this does, this is saying for type variable name, which is read as like in here. I don't know what we're going to say. In the collection. Now you can use it in more than just arrays. So I'm going to say collection, but in this case is the array here. We'll say array. So for type variable name in the array, we'll do something here. Right, so for every score in the scores array, let's loop through and get the value out. So the individual value is now called score. So I can say, hey, if the score is greater than the highest score, I have a new highest score. If the score is less than the lowest score, I have a new lowest score. And I want to take my total score plus equal the score. So 3 things. Check if it's the new highest, check if it's the new lowest, add it to the total. This will loop for every score in scores. When I'm done then, I can print out the highest score is going to be the highest score. And I can print out the lowest score is right plus the lowest score. And then I can print out the average score is my total score divided by my scores.length. Right, the number of values there. Now the problem with this is I'm getting integer division here. So an int divided by an int, I'm going to get an integer result. So I probably actually want this one to be a double here. Because if I have a double now, to avoid int division, I'll get a double result. Because scores.length is always going to be an integer. You can't have half of an integer stored in memory. No good here. It's always an int. So now I'm going to make sure I get the proper division result here. So we should get a highest, a lowest, and an average. Highest was 100, lowest was 92, average 96.8. Probably correct. Now we can go add them up ourselves if you wanted to double check Java's math here. See, yeah, I can't even hit like Windows R for run. That's okay. We'll do the calculator here. Let's go add them up. Just double checking here. So 99 plus 100 plus 99 plus 92 plus 94 divided by 5, 96.8. Look at that. We checked Java's math. Looks good. So it's easier now to track a bunch of values. Now, you're stuck with values of the same type, right? I can only store integers in this array here. I could do an array of strings, I could do an array of characters, I could do an array of doubles, I could do an array of rectangles if I wanted. Again, we'll get to it later. Don't worry too much about it. We'll talk more on Wednesday. But you can store multiple values, right, as many as you want, in a single variable, essentially, here, and then you just get at them by different index value. So index 0, index 1, index 2, and it can be any number of them here. Right, so it's an easier way to store multiple values because then we can loop through them, whether or not we're using the read-only loop or this sort of, this looping by index is very common here. Now, some people like the word I instead of the value index. Again, I'm really partial to better variable names, and honestly, I get confused when I see I. And there's nothing wrong with I, and people use it all the time, but I like just spelling out the word index, because, I mean, it's just as easy here. It's a couple more letters of typing, but most of the time it does the typing for you. So if you see I, it's not wrong, and the book will use I all the time, because that's what people like to do, but I prefer to spell it out. And then when we get to more interesting stuff on Wednesday, it'll make more sense why I prefer index. Okay? All right, so I think we're pretty good. I want to leave some time here to practice our lab. So let's go and we're going to do essentially the same thing here, but we're going to add another step. So what we're going to do is we're going to ask the user how many scores do they want to enter. So this value here can be a variable, right? This can be, say, score 1 here. I don't know, like 5 minutes ago maybe, SB Java. I have to go back and look. So the size here can be a variable. It doesn't have to be a fixed number. So you can ask them, hey, how many values do you want? I'm sorry you're having so much trouble, SB Java. It's definitely a weird Monday. And then you can size an array to that size. So we're going to ask the user, hey, how many scores do you want to enter? And then we'll make an array of that size. Then instead of coding them in here, inside of my loop, I can say, hey, what's the value at? And then assign that value. Right? I can say, hey, what is the score for index 0? And then I can assign scores at index equal a value here. Okay, so that's what we're going to do, and we're still going to calculate highest, lowest, and average. So the only piece we're going to change here then is adding in prompting for the array size and then looping through it. So for me, like, you could ask how many students I have in a class, and I can say I have 17 students. Let's go add a bunch of scores. That sort of thing. All right, so we need our classroom link. Let me start up a new lab. So this will be lab 10. Do a Java template. Yeah, it'll error out if you don't have enough memory at runtime. Hard crash. All right, so we'll copy our link here. We submit the feedback pull request URL. So this will be for next week, 28th at 10 a.m. 10 points. Don't forget there's study group tomorrow, 5 to 6, and then study group Wednesday after class, 12 to 1. Definitely encourage you folks to go there. It is well worth your time to go and get some extra practice here. Create a program that asks the user how many students are in their class. Create an integer array of that size. Loop through the array, asking the user to enter the score for each index value, and calculate the lowest score, highest score, and average score, displaying the results. Okay? And just some practice with the arrays here. Oops, sorry, my phone here. No, that's fine. Don't need that. And I forgot to name it here. Let me change the name. This is Lab 10. Lab 10. This is arrays. Okay? All right, so we got the rest of today to work on this, another half hour or so, and we can go from there. Okay, folks? Any thoughts, questions, concerns? Oh man, I gotta get graded on the rest of this stuff. All right, if not, you folks take care, and I will see you on Wednesday. Bye, everybody.